In this video, we'll talk about a problem in the long list of the IMO 1969. The problem was proposed by Chick, which states that if we have n non-negative integers, then look at the product of their factorials, k1 factorial, k2 factorial, product all the way to kn factorial. Then we have an inequality that this product is greater or equal to the factorial of the integer part of the average of those n non-negative integers raised to the power n. So this is the inequality. The proof is not too complicated, but the idea is very smart. So now let's talk about the idea of the proof. Now I have n integers k1 through kn. You can think of the situation as we have n kids, and we have capital K many apples. What we do now is that we are going to assign those k apples to those n kids. And we suppose they get initially k1, k2, all the way to kn many apples, respectively. Here, of course, k1 plus k2 plus all the way to kn is equal to k. Now look at what the right hand side is. This k divided by n is the average number of apples each kid will get. Of course, this is not necessarily an integer, but roughly it is the average number. So now let me write it down. Now observe that the right hand side is close to the left hand side when every kid gets roughly the same number of apples. This reminds me that if we fix this capital K and let those k1 through kn vary as long as their sum is equal to k, then the minimality of this product might be reached when those k1 through kn are roughly equal. Given that their sum is fixed. They may not be strictly equal, because k might not be divisible by n. And now here's the key idea of the proof. The idea is that if we let the kids who get more apples than others to pass their apples to those kids who get less apples, then hopefully this procedure will make this product smaller. And we will see in the details of the proof that this is indeed the case. Now here is the formal proof. First, we make a quick observation. We observe that m factorial times n factorial is bigger than I minus 1 factorial times n plus 1 factorial whenever m minus n is greater or equal to 2. This can be verified immediately because this first line is equivalent to, if you divide both sides by m minus 1 factorial and n factorial, this is equivalent to just m greater than n plus 1, which is in turn equivalent to m minus 1 greater than 2. Now, what does this observation tell us? What does this tell us? This tells us if we let the kids with at least 2 more apples pass their apples to the kids with fewer apples, then each passing will only decrease the quantity, product of factorials. And we keep applying this procedure until no kids can have at least 2 apples than other kids. And this, of course, will end in finite steps. Inductively, we get k1 factorial product k2 factorial all the way to kn factorial is greater or equal to the final state, where some kids could get just 1 more apple than other kids. So the factors in this product will be, in some places, you get the floor of k divided by n plus 1 factorial Well, in other places, you're just going to get some product of k divided by n floor factorial. So there will be 2 parts in this product. But in the end, you also know that the summation of those integers in the factorials will be equal to k. So summation will be equal to k. And the product is, of course, trivially greater or equal to k divided by n floor factorial raised to the power n. Because in here you get n many factors. And this is the inequality we want. And we are done.